Hey, 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 if it isn't Sawyer showing off another e-power project. Yeah, I made another one. I'm not sorry for it. Anyway, this is my GTX 980. You might recognize this card from the repair video I did. The repair video was fine. But I kind of broke the card basically the day after I made that video. And I broke the card in a way where, the VCore VRM controller was kind of dead. So, I could have repaired that, but I just kind of felt like, just hacking on an e-power is easy at this point and probably more interesting. So I just kind of did it. And the reason why I did it now was also kind of boredom. Like, I was planning the next video on the channel to be about this thing, running Sub-Zero, and I did quite a lot of attempts to do that. Like, the card's been Sub-Zero, I already have some results. Like, there was one run that was kind of decent, but this card, I mean, look at it. It has issues. It is very, very temperamental when Sub-Zero, and it's giving me kind of a hard time to get a good video shot with it. I'm still gonna keep trying, but in the meantime I felt like let's just work on something different for a bit. And then the stars kind of aligned because, well, I had this 980 also prepared to just receive an e-power for a while now. And I had, around the same time, figured out how to make the memory output work on the GTX 480 e-power boards, which means this e-power would now work with the card since it needs core and memory e-powered. And I also received the first parts of my new soldering station. I'm still waiting for some, but most parts that I need for it to function are here now. And I wanted to try it on something, and what is better to test out a soldering station than to do an e-power? So I decided to do that. So this is my newest e-power project, and this is what I would say actually mostly finished. There is not many things that I would change about this, other than maybe cap mods. I always keep the option open to throw more capacitors at the problem if I want to. I don't really consider it part of the project. It's more just whenever I have a car that I think could go a little faster, I generally throw capacitors at it. Other than that, this thing is basically done. It's not the cleanest implementation ever, especially on the e-power side itself, because this is the e-power where I figured out how to make the memory VRM run. So this is a sort of prototype e-power. This is the one that I built on camera, and it's not the most tidy e-power ever. If you look at the back of it, it's kind of a mess. But not really in a way that's an issue. It works just fine. It just doesn't look as tidy. My way of shorting the 8-pin to the PCI Express 12 volts is this, which is not fully proper. The 500 ohm resistor just kind of hangs out here. That's used for enabling the memory VRM. If you didn't catch the video, in order to make the memory VRM work on the GTX 480 power boards, you literally only need a 500 ohm resistance from the output to the feedback pin, and then it fires right up. After you give it 12 volts input, of course, because the memory VRM is powered off the PCI Express slot, which on an e-power, well, no longer is there, so you need to get 12 volts from somewhere else, like the 8-pin in this case. So I used my new soldering station to attach the e-power to this, and it was very easy. There's gonna be a dedicated video about the soldering station once all the parts are here. It was so easy compared to the old soldering iron I have. Now, admittedly, the new soldering station costs about twice as much as both my old soldering irons combined, but goddamn is it worth every penny, because it is so much better than the admittedly cheap POS, just garbage level beginner soldering iron I had. It's fine for general soldering, but if you want to do stuff like this, you very much want to have a proper soldering station. And yeah, like that was basically just the... Well, the point was to have a working 980 again, because it's my only 980. But it was also the point of just like, let's test the new soldering station. Also, let's use this EPOW for something now where no both outputs work. And yeah, like now I have a 980. Performs pretty well. Like the connection quality is a lot better on the than the 780. Like it also just has more connections. Like we have 8 grounds, one really fat vCore, and one also kind of fat memory. And yeah, from all I can tell is this performs really well. The way how I gauge this is, so in my experience and also in the experience of others, when you e-power memory specifically, it tends to have really, really big issues if the e-power is not just perfect. Like you tend to lose a lot of memory clock if you don't properly implement your memory power. And this card is overclocking the memory just fine. It's doing above what is typically expected for Samsung chips. Like it's doing over 4000. So yeah, memory is just fine. And if the memory is just fine, the core's gonna be just fine as well, because look at this thing. Yeah, like connections could have been a bit shorter, yeah, but I don't think it matters. It's a GM204 based card. It's not gonna draw enough current for this to really be an issue. And yeah, I also implemented a new idea for hooking connections up to the e-power itself, because on these self-made e-powers you don't really have nice big convenient strips of core and ground. You tend to be limited to just like scratching off the solder mask in convenient areas, but that tends to, well, it creates a lot of fiberglass dust, which is really bad to inhale. You tend to damage stuff in the area, and it just takes a lot of time and it's quite tedious. So I thought, okay, let's just take a small copper strip and just short all available vCore or ground things together with that copper strip, and then connect my actual power connections to that copper strip instead of the e-power itself. And that way I can just use all the connections, can make use of them, instead of just like, yeah, connecting each like little connection strip to like one point where there's ground. Now I'm just connecting it to the small strip below it that just connects to all the ground spots. So that's probably not quite as effective as just scratching the solder mask, but damn is it a lot easier to implement. Similar idea for vCore. This was also kind of like because of clearance, because I do have a tip that fits in between the, like, in front of the inductors, but, you know, doing it like this is also just a lot easier, so I did it. So that's an interesting, yeah, that's kind of a good idea, I think, for anything that doesn't pull a lot of current. Like if you have something that pulls a lot of current and you really want like absolutely the best voltage regulation, you probably still want to scratch the solder mask. But for something like a GM204 card that doesn't draw a lot of current for how much power it's pulling even, this should be just fine. Like the card's working just fine. Yeah, like I this doesn't really have any operational issues. The only thing, again, is just the typical, oh, it's an e-power, so the LLC kicks in, and specifically, because it's an e-power, it's regulating the voltage on the output of the VRM and not at your thing that you're actually powering, because it's an e-power. Now, I indirectly figured out a way to do it, but actually got the idea from ASIC when he looked at how I implemented this. I could have very easily not soldered it here, but to the very last memory chip here, and now the feedback pin would have gotten its voltage reading from here instead of there, which would have meant that the memory VRM is now compensating for voltage here and not there, which means, yeah, we get rid of all the voltage drop that we have between these 2 points, which is kind of a cool concept. Now, this, of course, is probably a lot more useful for your core VRM, which you can very easily implement that for too. Like, just measure what resistance you have between feedback and vCore, disconnect the trace, put the same resistance on like a wire or something, and then connect that wire to the vCore side, like, yeah, to like a VCore capacitor on the back of the core. And there you go. Now you're regulating your voltage as this, with this as a reference instead of this. And that will just get rid of all the voltage drop you have past the output of the VRM. Now I was testing, I want to test that with the next e-power I make. This one, I would have liked to test it, but like the back of the e-power is very full of hot glue and stuff already, and I just can't really access that area to really get at anything. So it's not gonna be for this project. For this project, I'm just gonna have to work with the fact that, yeah, the idle voltage on this is gonna be quite high, and then I just set my voltage under load, and then idle is gonna be quite a bit higher than that, just because of all the voltage drop that happens. But it should still be fine. Like, the 970 I did was fine, and the 970 is way worse than this thing, so I am not really concerned. And yeah, are there any other things that I did new? No, not really. Okay, so the one issue this thing has is PEX is again shorted to VCore, because the PEX VRM on this didn't want to power up for some reason. I don't know why. I just shorted PEX to VCore because I wanted the card to fire up. This potentially causes issues. I have a suspicion that this is what made the 780 cold boot bug. If this card has the same behavior, I'm gonna have to fix that PEX rail. If not, then I'm gonna be fine with it. It's still not ideal. Like, the PEX rail is a separate rail for a reason. It also kind of works like this, but it's probably not recommended. So yeah, I will only do this mod if I absolutely have to. Or more like if, well, I mean, I could fix this PEX rail probably. It's just, it's less of an issue than it is just convenient to do right now, is basically, yeah. And is there anything else to say? Like, there's not really anything on the back of the card except my voltage measurement lines, which just go here and then plug into my EVC. So I guess we could go to overclocking results. So I've tested the card already a bit, like I already talked about the memory. It does 4100. So that's a pretty good memory clock from what I know about Maxwell cards. Like, it's way better than what my 970 does. The memory on that one is really bad. So yeah, memory is just kind of good on this one. I think that some power up my 980 Ti does, also Samsung chips. So yeah, memory is just fine on this. And the core also seems good, at least. So the thing with the core is, when I tested the e-power, I actually was running a slightly undervolted core voltage, because under load, I set this thing to get 1.17 volts to the core, and the stock voltage for these cards is actually 1.206. So it's running about, 30 to 40 millivolts below stock voltage. Which is like significant enough to actually start having problems with core clock. But however, at 1.17 it's already doing mid 1400s. I don't know exactly where the limit is. 1430 works, 1450 doesn't. I don't know if 1440 works. I didn't test it that much, but like, it's getting into the mid 1400 range while being undervolted. So there's a fairly high chance that once, the card gets higher voltage, once I should actually increase VCore, that this card is gonna get close to or even get to 1500 on the core, which is really good for Maxwell. Like 1500, as far as I know, pretty hard to do, like with stock voltage. So yeah, it seems like the card is overall of pretty good quality, which is of course great because it's my only 980. So yeah, it's gonna be good that I have a card that's actually great at overclocking, even with this thing strapped to it. So yeah, I will bench it more at ambient. Like, it's gonna go through the entire course of maxing it out on ambient, checking for voltage scaling, and then at some point it will be run sub-zero. It's not gonna be the next thing. I still wanna do the 780. I just wanna be done with this thing. Like, yeah, I just wanna be done with this thing. So next Sub-Zero project is still the 780, but this thing's probably after that. And yeah, like, I mean, it's Maxwell. From running my 970 Sub-Zero, I got fairly close to 2 gigahertz on my 970, and the 970 is like not great quality overall. Like, the memory's kind of bad, the core also doesn't seem to be that great. So if this is a pretty good core, that might be a 2 gigahertz core with my phase change, which would be kind of cool. Like, yeah, 2 gigahertz on Maxwell is just kind of a neat thing to do. So yeah, that might be a thing. And I guess with that, I pretty much have said everything I wanted to say, didn't I? Like, yeah, it's just it's a new, fairly clean e-power project. Pretty much everything I wanted it to do, it does. Implementation could be slightly cleaner, connections could be slightly shorter, but you know what, I don't really care. The card doesn't draw enough power for it to matter. And at the end, the card works fine, and I managed to use the Z-Power for something. I managed to test out my new soldering station, and of course I had a lot of fun while building this thing, which is like the main factor. I just like building e-powers because I think it's fun. And yeah, so with that, until next time, and goodbye.